Salt seems like the simplest ingredient in your kitchen, but not all salt is the same. Some popular salt brands are heavily processed, stripped of natural trace minerals, or mixed with additives most people never think about. This is personal. Many people use salt daily, added to nearly every meal. Which salt brands raise the biggest concerns, and which two are actually worth using? Let us begin with number 5. Number 5. Great value. Iodized table salt. This is the kind of salt found in millions of kitchens, marketed as pure, affordable, and essential for daily use. The packaging lists only salt and an iodine stabilizer, but gives no information about where it was mined or how it was processed. There is no named source, no named refinery, and no practical way to trace its path from the earth to the table. What happens between extraction and packaging is left out of sight. That lack of transparency stands out in an industry where most brands at least hint at their origins. The salt is heavily refined, stripped of nearly all natural trace minerals, and standardized for consistency rather than nutrition. The result is a product that looks simple, but whose journey remains almost completely hidden. For something used every day, that information gap is worth noticing. Number 4. Morton iodized table salt. Morton iodized table salt sits on countless shelves, recognized by its blue packaging and by the promise that it will pour smoothly even on damp days. Its slogan, "When it rains, it pours," captures the brand's focus on flow rather than natural composition. What makes that possible is not just the salt itself, but a chemical additive called calcium silicate. This anti-caking agent, included at levels up to 0.7%, keeps the grains from sticking together. Ingredient lists also show dextrose, used to stabilize added potassium iodide. Before it reaches the table, Morton salt goes through heavy refining, including vacuum pan evaporation, bleaching, and repeated washing. Those steps remove nearly all natural trace minerals, leaving behind mostly sodium chloride and a handful of engineered additives. The result is a product designed for consistency and shelf life, not for preserving the complexity of the original mineral source. For something labeled essential and pure, Morton's formula is carefully constructed for performance, more than for natural simplicity. This is a clear example of a household salt engineered for industry, not just the kitchen. Number 3. Generic store-brand iodized salts. They sit on the lowest shelf, sold as plain, affordable table salt. Many people reach for them because they are inexpensive and familiar, and the packaging promises something simple: just salt. A recent independent lab survey tested 23 retail salts from across the country and found microplastic particles in every sample. Researchers used FTIR analysis to identify tiny fragments, remnants of packaging, processing equipment, or environmental exposure mixed invisibly into the salt crystals. The average count exceeded 100 microplastic particles per kilogram, with no exceptions among the brands tested. These particles are not listed on any label, and they are not a deliberate ingredient. Most likely they enter the salt during large-scale refining, packaging, or transport, slipping past filtration systems designed for larger contaminants. While the health impact of ingesting microplastics at these levels is still under study, their universal presence in generic table salts is now established. For a product marketed as just salt, this hidden contamination is a measurable physical reality. It is a clear reason for caution when choosing everyday table salt. Number 2. Himalayan pink salt, common imports. Himalayan pink salt sits on store shelves as a symbol of purity and wellness. The crystals are mined from ancient rock deposits in the Kira region of Pakistan. Brands present it as a premium, unrefined alternative, promising natural trace minerals and a closer connection to the earth. But independent laboratory tests reveal a different picture. Multiple batches of imported Himalayan pink salt have measured lead concentrations above 2 milligrams per kilogram, levels that exceed regional safety guidelines in countries such as Australia. This is not a rare outlier. The geology of the Kira mines, formed over millions of years, means veins of salt can run alongside deposits of heavy metals. Unlike microplastics, these contaminants are not introduced by packaging or processing. They are embedded in the mineral structure itself. Daily consumption matters. Lead in particular poses risks even at low levels when consumed every day, especially for children and pregnant women. Despite this, few brands provide batch-specific analysis or disclose test results on their labels. The image of Himalayan pink salt as a safer, more wholesome choice is at odds with the documented presence of toxic metals. For a product that commands a premium price and claims to be closer to nature, the lack of consistent third-party testing and full transparency leaves a gap between promise and reality. Choosing salt for its color or supposed mineral content means little if the source itself is geologically compromised. Number 1. Diamond crystal iodized table salt is the ultimate example of industrial engineered salt. On the shelf, the box promises purity, nothing but essential everyday salt. But the ingredient list tells a different story. Diamond crystal lists sodium chloride, dextrose, potassium iodide, and a flow agent called sodium ferrocyanide, labeled E535. That flow agent appears on labels for major US brands, and it shows up in a product marketed as a kitchen staple. Sodium ferrocyanide is not a flavor enhancer or a mineral source. It is an industrial anti-caking agent. Its job is to keep salt grains dry and free-flowing, even in humid storage or transport. The European Food Safety Authority re-examined this additive in 2019 and flagged potential concerns about cumulative dietary exposure, especially for people who consume salt daily from multiple sources. The United States Food and Drug Administration continues to allow sodium ferrocyanide at low levels, while the European Union has urged manufacturers to monitor and limit its use. Diamond crystal salt goes through a multi-step refining process that strips away virtually all natural minerals, leaving a product that is over 99% pure sodium chloride. Every trace of magnesium, calcium, or potassium is removed and replaced by additives designed for manufacturing efficiency. The result is a salt that looks simple, but is built for the demands of large-scale production, not for preserving the complexity of its natural origins. For a brand that advertises itself as pure, the reality is a formula shaped by industrial priorities and regulatory loopholes. This is salt rebuilt from the ground up, engineered for the supply chain, not for the table. Jacobsen Salt Company, Oregon C. Salt stands apart from the mass-market salts found on grocery shelves. Harvested by hand along Netarts Bay on the Oregon coast, this salt is produced in small batches using traditional evaporation methods. The company publishes a detailed mineral analysis for each lot, listing levels of magnesium, calcium, and potassium that remain intact through minimal processing. Unlike commodity salts, Jacobsen makes its lab results public, including a 2024 independent summary showing lead and cadmium below detectable limits. Each batch is tested by third-party labs for heavy metals, and the results are posted directly on the company website, offering a level of transparency rarely seen in the industry. The salt itself is free from anti-caking agents, bleaching, or any additives, and its texture comes directly from slow evaporation and careful raking. While ocean harvesting means the salt still depends on the cleanliness of local waters, the combination of traceable sourcing, published mineral content, and clean lab results makes Jacobsen a reliable choice for those seeking a simple, well-documented alternative. This is a salt where every step, from bay to table, is open to scrutiny. Icelandic flake salt is produced on the edge of the North Atlantic, where cold, clean seawater is drawn and evaporated using geothermal energy. This process relies on naturally heated water from Iceland's volcanic landscape, eliminating the need for fossil fuels or chemical intervention. Unlike most salts, the evaporation happens at low temperatures, preserving delicate minerals like magnesium and calcium that are often lost in high heat refining. No anti-caking agents or stabilizers are added. The result is a crystalline flake that forms slowly, layer by layer, with a structure shaped entirely by time, temperature, and natural mineral content. Recent independent laboratory analysis, using FTIR and density separation methods, reported no detectable microplastic particles in tested samples. The salt's purity starts with the source. Icelandic coastal waters are among the least industrially impacted in the world, and routine testing confirms the absence of heavy metals and synthetic contaminants. Each batch is traceable to its origin, with test results available for review. For those seeking the simplest possible salt, minimally processed, renewable in production, and verified clean Icelandic flake salt stands as the clearest choice. Across all 7 entries, one pattern stands out. Even the simplest ingredients are shaped by hidden processing and additives. In salt, purity is not a given. It is a question of trust and transparency. That lesson matters. What we overlook daily shapes our long-term health. Stay curious.